o'clock. This is the Zoom meeting for Thursday, the 4th of June, and we're doing Steve Ells on his engines repair. And there are some people already here, so here we go. It's being recorded.
Do we have anybody not in the United States that's online? Everybody is, microphone is muted, so possibly in the bottom left of your screen will be an icon with a microphone. If you're not in the United States, please sound off and let us know who you are.
Go for it, Jim.
Okay, do you remember the fellow in the Cirrus who...
Hello, good night to everybody.
We hear you, Felipe.
How are you? Good night to everyone.
Hi.
I am, my name is Felipe Di Costa from Colombia. Can you hear me?
Yes, we can. And we see you.
Okay. Okay, we only have two pipe PA-24s here in Colombia. I am the owner of one of them. We converted it to, we put a 325 horsepower engine, Lycoming 540. And it goes real nice. So it's a pleasure to meet all of you.
Good.
What kind of PA-24 is it? Which model did you convert?
This is series. The series is 333. So it's 1969.
Yeah, I'll bet it goes really, really fast.
Yes, it flies very nice. It cruises pretty good. It has a turboprop, and we have a lot of mountains here. So we really need them go real nice with our country because we have big high mountains that we have crossed around the country. So it goes very good. It cruises around between 155 and 165 knots ground speed.
Great.
I think Jim's iPad #1 there, that moniker, I believe he's from Australia. And his mic is off, so he can't confirm it.
Yeah, that's correct, yeah.
Yep.
Oh, what time is it local where you are?
Oh, it's 9 a.m. 9 in the morning.
9 in the morning? Okay.
Yeah.
So you're plus 14.
Yep. We were talking earlier that if we decided to try to do this in the morning, like 10 o'clock in the morning here, it would be 2 o'clock in the afternoon in Europe, and it would be noontime in Australia. And it might work out to be a good time, assuming nobody's going to work.
Well, one
Is
of
that
the
big
ones that
time?
we, oh, sorry, Jim.
How can it be day everywhere? It has to be midnight. Wait a minute.
Yeah. For the UK. And one of the guys from Cyprus, Turkey, was saying, it's 2 in the morning his time. So we do have a request from Matt Kirk of Comanche Gear and Hans Newbert. They're going to present on some of the stuff we should be watching for to get rid of some of these gear collapses. And they want to do it a little bit earlier because Matt Kirk is usually ending his day by 7 Eastern. Right around now, he's done. We're adaptable. We just need to get the info out. Hey, how are you? Hi, Lonnie.
Oh, hey, so good to see you. I've got a question for the group. I have a 1960 180 with an oil door to nowhere, and it also has a stall warning light, and I can't see in the law books that was ever installed. I'm wondering if I really had a 250 that they stuck a 180 engine in. Were there any 180s with 250 oil doors?
I'm flying Sean Cash's 1962 180 right now. Let's see. It's up for annual, so it's on jacks right now. But if I brought it over, well, the cowling, but let me just make everybody dizzy for a second. I'm not sure the connection's going to stay up because the hanger's not good, but you will see.
The answer is the cowling is the same.
Are you ready?
250. So that oil.
Yeah. They're all the same.
Not required in the type certificate data sheet to have a stall warning in a 180.
Right, but I have one, and there's not a
Same
law book.
oil door. Can you see it, Lonnie?
Yeah. Thanks, CJ.
Thank you, CJ.
Okay. So all could be converted to these, right? Well, I have a gentleman from Alaska that wanted me to call him, so I'm gonna put this down for 1 second and see if I can get him on.
We got right now an even 24 people.
Hey guys, so where are we with the fly-ins? I understood Oshkosh. Kristen had her deal, and there were some others. Are there any fly-ins planned?
Right now, we still have the one at Resnick on June 20th. That is still a go.
Where's Resnick?
Ellenville, New York. It's just west of West Point.
Okay.
Is that November 89?
I believe so. Yeah. I was going to give you a quick tour of the website, along about 20 after, because people have been asking how to get to the list of these meetings and the recordings of these meetings. That's all on there. So I'll give you a quick look at the fly-in schedule also.
Beautiful.
The one in July is at Katama, and of course that one's still on too. And then August is Sky Manor.
You better explain about Katama, Pete, why it's so cool.
CJ, you're phasing.
Never have.
I am phasing. I've got to call Roger Sullivan in Alaska. See, I've turned off my video to see if I can.
CJ, you're breaking up. You're about 2 by 5.
Okay.
That was better.
I'm gonna walk outside into the thunderstorm.
Well, it sounds like you're about neck high in the water.
Is that any better?
Yes, it is.
Okay,
5 by
great.
5.
Excellent. Now I know where to stand.
And might want to search around for a chair so you could sit, because you'll be up for like a good at least hour and a half here.
True. But I got a little preview of Steve's presentation last night, and I know I'm going to be like locked to the screen.
I'm here at the airport because they have good Wi-Fi that's trustworthy, but I'm sitting on a couch that actually converts into a bed, so I'm all set.
We can go as late as you want.
CJ, I want to tell you, we appreciate all of your Facebook posts of your adventures and career. It's great to watch.
You're funny, Lonnie. Thank you so much. I didn't think I was putting that much there, but glad it's entertaining. Hi, Bill.
Hey, I'd like to say I should be back home tomorrow after learning how to drive through torrential rain in Florida. I can't believe how difficult it is today. You drove through about 6 or 8 hours of it, so we'll be back. But I plan on trying to get a conference call on GAP Tuesday or Wednesday of next week.
All right.
Cool.
I hope we can get that in. I've just sent out quite a bit of material, and I was hoping to get some reply backs on it. But I think the conference call will help put that together.
I think it will, Bill. It's really important. Oh, sorry, Pete, go ahead.
I looked at it and it looks pretty good, Bill. I don't think I have any complaints at all.
Well,
I want to mention to the group, I'm sorry, I don't want to interrupt anybody. I want to mention to the group that if your biannual is overdue, like mine is, I called the FSDO and there's forbearance for a biannual, but you must complete 3 wings credits. And after you get the 3 credits, then there's a forbearance. And I don't know how long it is, but if anybody else is in the same position, there is forbearance.
That's good news, Lonnie. We'll try to get that word out. The particularly good news about that is, I mean, I'm out in the middle of annual right now, but the FAA has been in touch about these Comanche Zooms, and it looks like we are in the process of getting them approved. Not all of them, but anything that fits within the FAST Teams mandate, like this one, which Steve said he's willing to give again, will qualify for wings credit. And it'll qualify for AMT. So if you're a maintenance tech, it'll cover both. Yeah, come hang out with your Comanche friends and fix your wings problem.
Yeah, no forbearance for annuals. We just completed ours last month, but there is for biannuals.
It's doing those wings
Get
things
your forbearance.
online is
Oh.
a nice way to fill some time.
Oh, for BFR, sorry. Well, we've got a group, and before we start the sort of going around introducing each other, we're working out the process right now that we'll use, and we were figuring to, we have 2 choices. We can either make it inclusive in that anybody who's signed up for wings credit that signs up for the Comanche Zooms, as long as they're using the same email address for both the wings, the FASafety.gov, and for the Comanche Zooms, you would automatically get wings credit as long as you met the connection time. The other option would be to say that only people who opt in would be getting wings credit. Does anybody have a preference? I mean, if people could just jump in and say, I think it should just be automatic, or we should opt in. I'd love to hear that, because we're sort of designing the process now.
When they do the wings seminars, the live ones, there is always a sign-up list. You can go to the seminar and sit there all the time and then walk out and not sign a thing and not get credit. So I think that's the way we should do it. If you opt in, if you sign up, then you get the credit. If you don't do that, you don't get the credit.
There also has to be a
Okay,
time
just
on it as well, so that you just don't have somebody that comes in for 2 minutes get the full wings credit. And the Zoom process allows tracking of how long somebody comes in. So there's probably going to be some sort of nomination and confirmation process that if somebody wants to get credit, but they've only were at the Zoom for 12 minutes, that probably shouldn't cut it. So we should consider if the lecture is an hour, they need to be there for at least 85 or 90% of the lecture or something in that neighborhood, or maybe that's something that could be brought up for discussion with the FAA. Thank you.
The FAA's already said that it's going to be, there is a required minimum connection time, but Zoom will report that automatically. So Bulldog suggested it should be automatic. Pete's suggesting it should be opt-in. Maybe we'll just hold the survey and figure it out.
I think we ought to send in $5 to the Comanche Foundation, then we'll give them credit.
So I've done dozens of these over the last couple of years, or maybe more than that, and it's varying degrees. I mean, never have I had them make you stay to the end, but usually they either just you sign in and they check you at the beginning, or what I've also seen is they put like a keyword at the end of the presentation where it says, email this keyword, Northeast Comanches or whatever, and then that shows that you made it to the end. But usually it's been pretty simple and not overly cumbersome. But all of them required sign up.
Okay. Yeah, they said definitely everybody would need to go to faasafety.gov and register for the WINGS program. And then it becomes a question of, do we make everybody coming to a Comanche Zoom opt in to get the WINGS credit, in which case we would only share those people who opted in with the FAA? Or do we say, here's who came, and then they would do an email check and automatically grant the credit? So those are the two choices. And that each one of them would they were looking at connection time, because now that they're going from in-person meetings to lots and lots of webinars, I think they're using connection time.
Does anybody know what, I do these a lot, but I've never used it for a BFR. How does it actually work with the BFR? My understanding is you also have to go out with an instructor and do flying as well. So it's not as simple as just you get the credit and you're done. Do you know anybody know what the exact process is?
The WINGS program is very well described on the Fast Safety site. You do 3 credits of class stuff, seminars, and you do three sections of air stuff. One of them usually involves a traffic pattern. Another one involves some kind of emergency procedures or something of that nature, air work. And the third one kind of is up to you. I've done under the hood as my third one. So you get there's a list of things, tasks that they would like you, they suggest that you do. The thing I was going to say too, though, if you're going to get WINGS credit, 1, you have to have a WINGS account. 2, they have to have your email address. And 3, you've got to go to a seminar.
Okay.
Well, the 3 WINGS credit does count toward your ground portion of a biannual.
Right. I've done it. I'm on WINGS number 8.
All right.
And that doesn't count the 4 that I had before they changed the numbering. Okay, I'm going to spend a few minutes here sharing the screen that I've got of the website, just so you can see what it looks like. This is, as you can see up there at the top corner, northeastcomanche.org is how you get to this website. And on the top line here are the different choices you can go to. The real quick look at the flying and schedule. These are for real. The ones that are crossed out are the ones we have canceled. So June 20th is Resnick in Ellenville, New York. July 18 is Edgartown, Mass, Katama Air Park. August 22 is Sky Manor. And right now, September 20th and October 17th they're not set yet, but that's what we're planning to do. There's also the AOPA fly-in at Rochester. So far, that has not been canceled. If I go back now to, oops, wrong one. There we are. Back here, the Comanche Zoom is one that everybody's been asking about. This is the list of subjects that we're going to try and cover with these Zoom things. We've done the medical issues proposal, owner-produced parts. The one that got away was Hans Newbert. The autopilots, we're going to come back to that. There's 3 of them about coming up. Falling off your log is from Kristen. And tonight we're doing getting the most from your engine is the one with Steve Ells. Each of these here, the titles are here are now links. If you click on the link, you get a page that describes what that was. And at the bottom is the link to go to the video or the audio. So it's all right there.
Wow, that's impressive.
Whoops, no, I just blew it away, didn't I? I'm sorry about that.
Again,
Can you still see it?
No,
Okay, I have to go back and share it, okay.
The idea here that Pete has so clearly put together is everything shows you from the Comanche Zoom on how to get to the audio and the video. And as it turns out on that last one, there were 2 parts. So listen to part 1 before part 2. What happened is the recording got fragmented in the middle. So we just continued recording it, and the parts are named separately. So don't think that they are duplicates of each other. No, part 1 comes first, followed by a shorter part 2.
It was internet interruptus. Looking ahead, aircraft insurance is next week with Lycoming. That was supposed to be this, we thought was going to be this week. And we were able to move Steve up to fill his spot. New life for old autopilot. He's going to talk about the original ones that were in the Comanches, the old style ones. Rob Leonard is was with the FISDO here in Connecticut and is a wings guy. And then here's the 3 on autopilots. These guys are coming back after having done a massive group thing back in the earlier time with the autopilots. And then part 43, maintenance, how to do it and how to log it. And speed mods, in case you want to do something. Something short of putting a 325 horsepower engine into your 180. Okay, end of share. We got about 7 minutes till it's time for Steve to take over. Of course, if you have any questions for Steve now, go for it.
Or just let's pop around and do some intros.
Okay.
I'm CJ and I'm in Seymour right now doing under annual. Flying a 180.
I'm Lonnie, fly a 180 also. And Lauren, there's her hand.
I am Tom Marino in Massachusetts, fly at 250.
Hi, I'm Russ Pasco, better known as Bulldog from the Navy side of the house. I got a twin Comanche, but I thought I'd join you guys anyways today.
Ron Mazel, I'm in New Orleans. I fly a 260B.
I'm Chris Burnley out of Belmont, California. I'm jealous of you guys that are able to get together there on the East Coast and wish we had more of that up here on the West Coast. And I fly a 68 260B.
I'll be glad, Chris, I'll be glad to help you do that because I did it for the Mid-States tribe.
Oh, yeah.
Hi, I'm Patsy for I fly a twin Comanche.
Hi, I'm Elmer Creech. I'm in Delaware, fly 260B.
Hank Spellman, Lincoln, Illinois. Get this identifier, Kilo Alpha, Alpha, Alpha. Fly 1959 250.
John and Deb Westerfield from Coleman, Alabama.
Aha. I just got a text message that someone's asking to be sure that we spread the word about these Zoom things, let other people know about it.
LJ Jimenez from Riverside, California. I fly a 59 250.
Craig Hammond from Fort Siloco, fly at 250. Bob Sandelis from Houston, 260B.
Hi, I'm Dave Shaver. I'm from Falston, Maryland. I fly a 65-260.
I'm Steve Ells. I live in Paso Robles, Kilo Papa Romeo Bravo. I fly a 1960 Comanche that I've worked on for 9 years now, and it's almost airworthy.
Wow.
Almost airworthy, and you do fly it, you said?
Flexible term.
Yeah. We have a guy here that's putting together a 120, and they've been doing it for 5 years. He just did a high-speed taxi today. It came that close to flying.
Wow.
Who flies the sunny side up?
Yeah.
Jack White from Nashua, New Hampshire. I fly a 1967 Twin Comanche using my office manager's account, Veronica Hamilton.
New Hampshire.
Yes.
Tell you what.
Hey guys, whoop, there we go. Hey guys, it's Russ from Florida. I fly 64 Comanche 180, better known as Sunny Side Up. Yep, a lot of fun. How y'all doing? Good to see you.
Jeff Gaskell here, 67 260B, had it 32 years and still love it.
I'm Margie Leggett from Pasco, Washington, and I have a Comanche 250, 1964 250.
Right.
Got about 3 minutes till Steve's on. We got 42 people right now online.
Amazing.
Just want to thank everybody. Yay.
Go, Bernie.
I'm Bernie Stumpf. I fly a 1968 260B, and I'm based in Rhode Island on the southwest corner.
I'll go. I'm Michael Saperton. I'm out of Deer Valley, KDVT. I have a 63 PA 24 250, and I've had it for about 4.5 years, and I love the thing.
Michael, what's your N number?
November 8258 Papa.
8168 Papa.
Oh, wow. Are you here in Phoenix?
No. I'm in Connecticut, but I was just wondering how close we were, and we're both 63s.
Yeah. Serial number 243511.
34 something or other. 16, I think. I'm not sure.
Yeah.
Okay, I'm Pierre. I'm from Sherbrooke, Quebec.
Aha.
I've got the 260B. Nice to be with you guys.
Yep.
Welcome, Pierre.
Okay, we're getting down to the end of it here. What I'm going to do now is mute everybody. And Steve is going to take over. You cannot believe what you're going to hear. Well, yeah, you can definitely believe it because he's telling the truth. But it is amazing the stuff that he will be able to show us tonight and tell us about. So, Steve, it's all yours. Unmute your mic and go for it. I would suggest everybody else goes to the speaker view because that way you can see him up close and personal. Up in the upper right-hand corner of your massive screen, there should be a thing that says speaker view.
Pete, can you enable screen sharing?
I can do that. Security, screen share, done.
Okay. Welcome, everybody. I'm glad you're here. I'm going to try to educate you. And we're going to learn about how to determine how healthy your engine is, some recommendations for how to keep it healthy, and a little fun along the way. So what you see on this picture is the Lycoming IE2 engine, which is a fully automatic engine waiting for somebody to buy it and put it on the airplane. It's automatically adjusted the mixture, automatically adjusts the timing for best angle of pressure inside the cylinders, and the only people that are buying them is Partenavia. No, that's not quite right. Somebody over in Europe. Anyway, but this engine would be what we could all put in our airplane if there was no lead, because lead goofs up all the sensors in these engines. So someday we'll get there. Okay, this is what mechanics run into once in a while. And you know, part of successful flying is good pre-flight. So always open up your cowling. Takes about 10 minutes for a bird to build a home in there. This one I found in my cowling of my 180 one day. And I had an open hangar, so that made it easy for Mr. Bird to settle in and build a family. This is a typical, this is the old exhaust I had on my airplane. I believe it was original, so it was 50 years old. You can see that it's been repaired before. Sort of somebody stuck a gobble weld on it down here, and it cracked again. So this is the evidence of it's cracked. You always want to be looking out for this kind of whitish powder on your boot cowl, which is the cowling original, just aft of your regular engine cowling, because it'll seep out there and it'll stain, and it's talking to you. So make sure you're listening. Okay, how do we keep the engines healthy? Do what it takes to keep the CHTs under 400 degrees Fahrenheit. That it's okay sometimes during extended climb on a hot day to let it creep up above 400, but you should try to do your best to keep it under 400. The tools you can use are reduce your climb angle, reduce your power if able, or enrich the mixture. And like I say, sometimes you're not able to reduce power, you're climbing out, you got a load, and you need all the rich you got to keep the engine cool. So, you know, sometimes it's going to go above 400, but if you have control of it, you're in cruise, you should be much cooler than 400 most times. So that's number one. During determining an engine health, one of the major tools has been since I went to A&P school back in 1970 is compression testing. And Lycoming has some very simple rules for compression testing. They're sort of soft rules. We'll get to them in a minute. But you can see here, the compression tester I use, basically you put the cylinder top dead center with it hot, if able. You put 80 pounds of air into the compression gauge, and then there's a little leak between the left side and the right side. So you're not putting full pressure into the cylinder. It's a calibrated leak, or a calibrated leak. So what the gauge on the right side will show you the health of the cylinder as far as compression goes. So in other words, we put 80 in this case, this guy's got, looks like he's able to hold 78 PSI, which is really good number. There's some more to talk about here, because a high compression reading does not always indicate that the oil rings are sealing well. If your engine, within 5 to 7 hours after you put nice clean oil in it, the oil's black as pitch, that's the compression rings are in not good shape. And I ran my engine like that for a long time when I was poorer. And you know, I just changed oils at shorter intervals, because what's getting down in there is contaminants and fuel, and that contaminates your oil. So some of the additive package in your oil is broken down when you get too much of those reactive components down in there. We'll talk about that some more in a minute. you can see in the bottom picture, the exhaust valve on the right, the intake valve on the left. I'm going to talk about a bore scope in a minute, but the exhaust valve, you can see a very good pattern on that exhaust valve. You can see around the perimeter of the exhaust valve how the color is almost uniform. There's no real discoloration. If there's any, it might be right about in this area, but it doesn't look bad right now. So that's exactly what you're looking for when you're doing a bore scope and you're looking into the cylinder. The critical valve is the exhaust valve because that's the one in all the heat. So here's what Lycoming says about compressions. It's a service instruction. It's SI 1191 alpha. They say a couple of soft rules. Compressions should be within 5 psi. A difference of 10 to 15 psi, investigate it. Don't take the cylinder off. Remove it in 15 hours. Most of you probably know that there's 2 compression rings on each piston, and each one of those has a gap between the ends because they move on the pistons a little bit, and they allow them to move. So occasionally these gaps between the 2 piston rings line up, and then your compression will go down a little bit. But the rings continue to rotate as long as the cylinder is not contaminated with oil residue or carbon, or the pistons aren't. So that's why they say retest it, retest it. It's not going to hurt anything if there's a slight split. They also say if compression is above 70, you're good to go. Compression's below 65, they claim there's wear, which should be obvious. You get a high time engine, it should be wear. They don't say anything about pulling a cylinder at that point. Below 60, consider cylinder work, and that's pretty soft admonition. Like I said, these cylinders hold compression really well. They're totally different from the theory and the practice of continental cylinders. So they use a nitrite hardened surface, which is really resistant to wear. So they don't wear out very much, not nearly as much as a continental, which is a whole different theory. So those are your guidelines. They're pretty flexy guidelines. Like I said, the old engine I had, which was a field overhaul from 1985, was still making good compression. It had some serious problems by the time I pulled it off, but it never quit making power. We'll talk about that in a little bit too. Here's one of the best deals for an airplane owner. It's a bore scope. This company called Oasis Scientific built this little Vividia VA400 bore scope. It's designed to go straight into a cylinder. Take out the spark plug, stick it in there. There's a little plunger on top of that handle, and you can bend the end around and rotate the handle to get a view of anything you want inside the cylinder. And then you can hook it up with a USB to your phone or your tablet. Take pictures. And I take pictures every time I go inside the cylinders, and I can compare them to later. So it's a handy tool. The other guy I work with out there at the airport, he just hooks his up to a Samsung phone, looks inside the cylinders that way. This is me getting ready to check out, do some little bore scoping action. You can see it's got a little light on the end of it, and that light is adjustable, so you can get the amount of illumination you want inside the cylinder. Here are a couple of cylinders that are obviously sick. You can see the bottom one, it's not only sick, it's about ready for the graveyard. That exhaust valve has gotten so hot that it's completely eroded away, the metal at the 10 o'clock position. And interestingly enough, this was off a big bore Continental turbocharged engine. So actually the owner did not have an engine monitor, and he did not know that this valve was burnt, because in a turbocharged engine, at least the Continental style, the turbocharger controller, the wastegate controller, will adjust as necessary to keep what's called the upper deck pressure at a set level. So if there's a leak in the system, it just tightens up the wastegate a little bit. The rest of the engine makes rated power, but without engine monitor, he did not know that thing was burnt till it was annual time. the top one, you can see the discoloration right here, you know, about 4 o'clock to 6 o'clock. That tells me, and will tell anybody that knows what they're looking for, that it's hot there compared to the rest of it, which means you're going to take that thing off and do whatever it takes to get it to seal well again. I mean, take the cylinder off. So the borescope really pays for itself right off the bat, I think. This is another picture of a valve, exhaust valve that's getting hot. This is also off of Continental. You can see Continental angles one of the spark plugs. So you can see the burn pattern where it's really hot in there, and none of this carbon or lead oxide actually, gets on the cylinder, the cylinder head in that area, but it's evident everywhere else. And that's another reason I'd love to get unleaded fuel, so we wouldn't have this contamination of the oil in the cylinder head, the piston, and the oil. But I've been talking to a couple of providers, and they say, oh, it's right around the corner, which is what I've been hearing for 22 years now. So I'm not actually holding my breath for unleaded fuel. If there is some unleaded fuel you can burn, it's a Swift 94UL, and I burned it in my airplane. I did not notice any difference at all, but there's only one station, one FBO in California that supplies it. It's about 120 miles away, so I don't go get it up there. There are a few places in the Midwest you can get it, and the places in the Midwest sell it cheaper than 100 low lead. So if you can burn it, if you find a place, I'd recommend it. Swift Fuels will list all the places that sell it. This is a picture I took of my exhaust valve in my 0360 with that borescope. Borescope cost is $249. You can buy it on Amazon. This has about 180 hours, so there's not much contaminants on it. You know, it's pretty clean inside there. And I'll show you some that have lots of hours. This set is off of 0320, and it's healthy. They're healthy. They have a lot of contamination on them, and this coloration is typical of 100 low lead. Both of these are exhaust valves, and there's no difference. There's no discoloration around the edges, which means the edges are sealing. Lycoming valves get rid of heat by what the heck is up in those valve stems? I'm thinking now here. Liquid something or other, and in the valve stem, they convey the heat up the valve stem, and it radiates out through the valve guide. So they don't do as much cooling on the valve seat. The Continentals do a lot of cooling on the valve seat. So you know, as long as that's one reason there's a STC, or a bulletin to ream the guides, to check the clearance on your valve guides, the valve stem to valve guide clearance every 400 hours. And because it's also the extreme heat up there, and the oil can create carbon in there and lessen the clearance between the valve stem and the valve guide. So have any of you guys ever heard of morning sickness? That's where your engine starts, but all 4 cylinders or all 6 cylinders don't quite join the party. One of them, and finally the thing starts up and running on all 4 or 6 cylinders. That's an indication you may be having a sticky valve. And when that happens, there's some testing you can do to determine which cylinder it is, which guide it is. You should be able to tell which cylinder it is actually if you have an engine monitor for the cylinder head temp reading. Anyway, so moving on here, another tool you can use that I use is oil analyses. This is a company I like to use. It's called Blackstone Labs. Every year at Oshkosh, I guess I'm not going to Oshkosh this year, but every year I typically will go and buy a 6-pack of oil analysis kits, about 120 bucks, and take them home, sit them on the shelf, and every time I drain the oil, I let the first quart run out, and then fill the little bottle, write down the details like the engine time, the type of oil, etc., and whether I use an additive or not, and then ship it into them. It's just standard mail. And within a week or two, they'll mail back a little report like this. And you can see that if you go from left to right in those readouts below the white part, you can see they keep a running total of the oil analyses. So you can compare, how you're doing all the way along. Another tool that Mike Bush uses is he breaks down the contaminants per flight hour. And I'll show you a little later how that works out for him. That's a good way to do it. He's a little bit more techie than I am, but that's what he does. Another thing that's often missed during oil changes is this plug right here. This is on the bottom of your engine, the bottom of the oil pan at the back end, and that's the pickup strainer. It's sort of a very rough, it's a tube with holes in it, and it's to collect the big chunks. So if you really think you have an engine problem, that's where you want to go first, because if you really got things falling apart inside that engine, they'll be right there. I'll show you a picture of what I pulled out. This engine right here came off for the bad engine mount I had. No, this engine came off because we were doing a complete overhaul. But you can see, I took it apart, some disassembly on the hoist there. This is the thing on the left there. That's that pickup screen, and those little black parts down there are what I found in the bottom of the engine when I took it apart. As I said, this engine was pretty tired by the time I got there. I had overhauled the cylinders, knowing that I had that bad oil control rings, put them back on, and created a big oil leak, and I couldn't stop it. And so I had a friend that had a machine shop, and we decided that we could rebuild this engine. An A&P, it's legal for an A&P to rebuild an engine. And so we took it off, and when I took it off, we took it apart, and I found it had a cracked main bearing journal, and but bless its little heart, that tough engine kept on running. It was ready for an overhaul. Like I said, I'm not sure of the competency of the people that built it in 1985. It was a field overhaul, but it kept running really well. I took it and I threw it all around and had some confidence in it. I've got much more confidence in this engine now. So if you have an oil filter, you always want to remove the can in the filter and cut the media off the can and the center tube and inspect it. And I cut it off. I either use an electric knife that I bought down at the Salvation Army or a hacksaw, and I just saw that stuff off the center tube there and look it over really good with a flashlight. If I see any metal at all, I'm going to put a magnet on it to determine if it's ferrous metal or non-ferrous. Often, especially in higher time engines, you'll see little black carbon chunks. You can tell if they're carbon. If you put your thumbnail on them and push down, they'll break apart. The lower picture shows some more of the schmutz I got out of that engine when I took it apart. A lot of carbon and a lot of, looks like seals actually. But so you always want to inspect everything, when you get a chance. That's the way to do the troubleshooting, to determine your engine's health. Okay, that's the wrong one, go back one. What do you do if you find metal in your filter? And how much is too much? Lycoming says, well, don't panic if it's a low time engine. All low time engines are wearing in or breaking in. There will be some metal produced as it wears together. All the parts start dancing together. they say if there's small pieces of sliver-like flakes or non-magnetic carbon, don't worry, put it back in service, check again in 25 hours. 30 to 40 of these small pieces, clean the screen or filter, change the oil, run it on the ground for 30 to 40 minutes, and then check again. It'll tell you if something's coming apart. Chunks the size of a broken pencil, lead or larger, pull the suction screen, which is that screen that's at the bottom of the pan. Usually this indicates some kind of cylinder problems. They suggest you pull the bottom plugs. You'll be able to determine which cylinder it is. Oftentimes when metal's bouncing around, it will smash one spark plug. The borescope also comes in handy there. A quarter teaspoon of metal, investigate. That's their suggestion. A half a teaspoon or more usually means the engine needs to be removed and disassembled. So there is some leeway there. It's not a either or situation. What's the maximum oil I can use and still be airworthy according to Lycoming? That's all in service instruction 1427C. There's a formula, 0.006 times the brake horsepower times 4 divided by 7.4 equals quarts per hour. So I did one example. For my 180, we had 65% power, which is 117 horsepower. The formula works out to 0.379 quarts per hour maximum consumption, or a little less than 1 quart every 3 hours. So my engine actually burns about a quart every 4 hours. And I'm not worried about it at all because it's very stable. And I also have chromed plated cylinders on my engine. And they typically are not, you're not able to dry them up as much as a steel cylinder. So I did one with a 250 horsepower Lycoming. Let's say we're running at 100% power, which nobody runs at 100% power all the time because most of the time you can't. But just for example, run through that formula, 0.81 quarts per hour max, or 1.5 quarts every 2 hours. So you can run a lot of oil through your engine and still be airworthy. It's the thing in every one of these pieces of information is when things change rapidly, or you notice a big change from one check to another, or you notice a big change in the amount of oil, the fuel consumption, cylinder head temperature, etc., change, that is talking to you. You need to investigate what happened to cause that change. Sometimes it's just you operating a little differently or flying a little higher, using different kind of oil, but any change is what you need to investigate. So I don't know if you guys know it, but you only get about 27% of the energy in a gallon of gas is turned into thrust in an airplane engine. This blue part, that's the thrust part. That's the power. This is exhaust. This is cooling losses, pumping losses, and friction. So how do we maximize that use of that fuel? It's going to take a look at what happens inside those cylinders as we lean the engine. So this chart is from GAMI, General Aviation Modifications Incorporated in Ada, Oklahoma. This is the rich side of the mixture. This is the lean side of the mixture. And you're going to see what happens to the EGT, the cylinder head temp, the internal combustion pressure, horsepower, and the brake-specific fuel consumption as we lean the engine. Obviously, as we lean the engine, the EGT goes up and up and up and up and up till it hits peak. Peak is when the weight of the fuel and the weight of the air combine completely in combustion. That's the hottest the engine's ever going to get, or the combustion process is ever going to get. As we do that, the cylinder head temp gradually rises and peaks out right about 50 degrees rich of peak. At it starts to drop before you ever get to peak, the CHT does. Same thing with the internal combustion pressure. It's almost parallel with the CHT. It's maximized out right about here, which is usually about 80 degrees rich at peak. And horsepower, I'm sorry, that's not correct. The horsepower maxes out about 80 degrees rich at peak. You can see it here. So if you want to run your engine where you get the most power, or the most power out of your gallon of gas, run it at 80 degrees rich at peak. That's not the most efficient, but it's where you get the most power out of each gallon. Now, the brake-specific fuel consumption, this is increases until you get lean at peak. So lean at peak, right in this area here, is where you get the best power per gallon of gas. You get good power per gallon of gas here, but it's not the best. So anyway, these are all things that happen within your engine as you lean, just to get an understanding of what's going on. Now, one thing that people don't understand about leaning, or not everybody understands, is something called the EGT spread. And there's a lot of talk, there has been a lot of talk, there will be a lot of talk about lean at peak versus rich at peak operating. I cannot operate lean at peak because I have a carbureted engine. The induction system and the carburetor are pretty rudimentary, so there's no chance I'm going to get even fuel air mixtures to each cylinder. This creates what's called an EGT spread. If you look here, these are the leaning charts of 6 different cylinders. And the fuel flows, right? So this guy over here, number 1, he peaks out about 14 3/4 gallons. This guy here, number 4, he peaks out about 13.5 gallons. He peaks out, number 3, peaks out about just under 14 gallons. The difference in gallons per hour between the first cylinder to peak and the last cylinder to peak is called the EGT spread. And why is that important? Well, because you're not going to get them all to peak at the same time. And you're not going to get them all to hit 80 degrees rich at peak for best power at the same time. It's just, unfortunately, the development of these engines. Now, if you have fuel injection, you have a much better chance of lessening the spread. In fact, GAMI will sell you a set of matched fuel injectors, which do a lot to bring that EGT spread together. In fact, they'll have you do what they call a lean find test. And in that, they'll ask you to fly at 60% power. You must have an engine monitor to make this work. And they'll ask you to write down what the fuel flow is as each cylinder peaks. So, you know, in the common engine, maybe you'll have like 0.7 of a gallon spread between the first and the last. Well, they'll tune up these injectors to adjust for that variance to get you down to where ideally you'd like to get down to 0.2 of a gallon spread. When you get down to 0.2 of a gallon spread, you can easily operate lean at peak because, number 1, all the cylinders will be producing the same power, and number 2, you won't be leaving one cylinder over in the real hot zone when the other cylinders are over on the cool side of peak. So you have much better control of the temperature of the cylinders if you have fuel injection and you have those GAM injectors. Now, why would anybody want to operate lean at peak? Oh, well, I got one more chart here. Best power fuel air ratio, where it produces max power for a fixed mass of airflow. Always be some mixture around 80 degrees rich at peak. Best economy fuel air ratio, which engine produces max power for a fixed mass of fuel flow. So that's the green line here. That's best economy. This is best power. And best economy depends on you know, if you're turbocharged or you're not, varies. Low power, which would be non-turbocharged, would be 15 to 40 degrees rich of peak. High power turbocharged engines, they can run over there at 40 to 90 degrees rich, Lena peak, excuse me, Lena peak is what I meant. So now, why would you care about such things? Why fly Lena peak? And I hate to bring this up because most of us aren't able to. I can't. Peak is what's called a stoichiometric, chemically perfect combustion, 16 pounds of air to 1 pound of fuel. Best power, 75 to 100 degrees rich of peak, burns approximately 20% more fuel than peak, yields 3% more power, and 1.5% more true airspeed. That's where most of us fly. Best economy, 40 to 70 degrees Lena peak, use 20% less fuel than peak, 10% less power, so you sacrifice a little power, but you save a lot of fuel, and 5% less true airspeed. So the numbers work out if you can fly Lena peak. It's not going to go quite as fast, but there's other advantages too. Let's take a look at those. Richer peak, there's all kinds of contaminants, extra fuel, extra lead, extra crud that builds up inside your engine. And all that stuff takes a toll. It accumulates here. You can see the exhaust port, accumulates on spark plugs, accumulates on valves, pistons, accumulates. This is an engine that's ran 1,000 hours, Lena peak. It's a TSIO 520. You notice, you see any contamination there? If there is, it's very, very minor. Big difference, big difference. But again, like I said, in a perfect world, we could all run Lena peak and gas would be $2 a gallon, but you know, it's not that way today. Next rule is we want correct ignition timing. Our magnetos are set to spark, the spark plugs at one point in the engine rotation. 1 point before top dead center in compression stroke. And this is, I made this picture on the left. These are two ways to set the timing. In other words, two ways to determine the crankshaft location so you can make the mags fire at a certain point. You can see you got that degree wheel on the front of the spinner. And then you can also use an inclinometer, as I put there on the prop. It's 25 degrees. You locate top dead center, then you back off from that. That's the way they do it pretty much on Continental engines. They also have a timing mark, but not all of them still have that because Continental took it off. On Lycomings, you can take a straight edge like this 12-inch ruler, put it right against the backbone of the two case halves, and it'll point at a mark on the what many people call the flywheel that says 25 degrees. So if the flywheel is installed correctly, and it's pretty hard to install it any other way, that's the easy way to do it. There's also a little dot on the other side of the flywheel which matches up to a dot on the starter housing to time it. So there's getting the crankshaft in the proper position to time your mags is not difficult on a Lycoming. Okay, let's talk about 500-hour magneto inspections. Why do we need to do that? Because magnetos wear. This is the point set inside a magneto. That thing opens up, it collapses the magnetic field in here, shoots a lot of spark, a high energy spark out to these towers. There's also a distributor in here which distributes the spark in the proper place. This little white plastic thing is a follower. That's what bears against the cam. So that wears because this felt here has oil or lubricant in it. That's supposed to lubricate the interface between the cam and the follower. After 500 hours, it's worn. When it wears, what we call the internal timing of the magneto changes. So you're no longer, when the internal timing changes, the external timing or the timing to the engine changes. When the timing to the engine changes, you're no longer firing the plugs at the ideal time. So I highly recommend that everybody pay attention to 500-hour magneto inspections. That's not a 500. That's not an overhaul. That's a 500-hour inspection. And typically, the shop I use, which is up in Missoula, Montana, Aircraft Magnetos, they replace the parts that are needed. And also, if you need any magneto advice, the guy up there named Cliff is one of the smartest people I know as far as magnetos. So, Aircraft Magneto Service in Missoula. I've known him for over 40 years. He knows his stuff. Okay, next solution. Make sure the baffling's in good shape. That's your cooling system. If there's leaks of the ram air into the engine compartment, you're compromising the cooling system. This is the new Lycoming engine on a 172. You can see that Cessna put a lot of energy into developing a very sophisticated baffling system, flexible baffling system. You know, if yours looks like it's been there 10, 15 years, sort of raggedy, you know, sort of that old black crap that may not seal too well, I'd recommend you call up McFarlane, MacFarlane, and get some of their baffle seal material. It's coated on one edge, so it will not abrade your cowling. The best stuff out there. There's a way to check the condition. Put your cowling on, stick a shop light, or any kind of light source up through the outlet at the back of the engine into the accessory section. Then look through the cooling holes, the ram air cooling holes at the front of the engine, and see where there's light leaks. Plug them up. Plug them up. You can use flexible silicone baffling, or not baffling, but sealant. You can buy it at any hardware store, or you can actually just restore all the baffle seals. It'll make a big difference. I haven't verified this, but somebody told me a 1 square inch leak of the baffling will compromise the cooling efficiency about 10%. I haven't verified that, but I heard that a while back. Excuse me. I recommend you install an engine monitor. That little gauge on the left, that's the sort of the first engine monitor built by Alcar, a man named Al Hundari developed it. It was on one cylinder. It was the EGT gauge. As you leaned, this needle would move up the face, and then when you got to peak, it would stop moving up and start moving back down. So then you take this little thumb screw and you adjust the red line to peak, so you knew how rich you were from peak. 25 degrees for each mark. Nowadays, we don't have to do that anymore. We have sophisticated engine monitors. This is the Electronics International CGR 30P and 30C I have in my airplane. You can see it. I got RPM, manifold pressure, fuel flow, fuel pressure, oil pressure. Bottom gauge has fuel left, fuel right, oil temperature, outside air temperature, vacuum, volts, carb temp, and amps. So, excuse me, this window up here, right below the manifold pressure, you can see this is in the EGT situation. I can push this button in here and select any number of displays. I can select rolling EGT CGHTs, where that rolls through the CHT and the EGT, each cylinder in succession. I can normalize a bar graph, where I put every EGT and every CHT. I normalize it so they're all the same level. So if there's any diversion, that's telling you a story. Something's wrong. I've diverted from normal. There's also a number of warnings, audio warnings you can build into this and wire into your audio panel, so you don't have to keep your eyes on it all the time. You also have the capability through a thumb drive, portable thumb drive, to download all the data. This is from a flight I guess I took in 2016. The green arc is RPM. You can see this is obviously takeoff. Could climb up to climb, and pull the RPM back to cruise. You can see these are all the CHTs, or excuse me, EGTs up here. They're married very well. You can see there's a little noise in the RPM readout, but that's just a connection problem. Down the bottom here we have the CHTs, and you notice how the big split between these CHTs? That's common in a Lycoming. You know, the 1 and what do we got? 1 and 2 are lower than the 3 and 4, and the blue line is the fuel flow. So, and in this program, actually, this is a readout I got from Savvy Analysis. If you want to download your data onto that website, it's free. They'll print you out and send you this back electronically. If you want them to analyze it, they have a sophisticated analog or algorithm which can talk to you and tell you if they see anything that's a little abnormal, and that'll help you. That's another way to gather information on the health of your engine. So there's lots of tools out there. Excuse me. How often should you change your oil and filter? The manufacturer's recommended oil change intervals are every 3 months, or every 25 hours if you have a screen, or every 50 hours if you have a full flow oil filter, whichever comes first. Most experts recommend 25 to 35 hour changes if you don't reach the 3 months in that period. Typically, just because the additive package in the oils, we'll talk about that in a minute, breaks down. The oil doesn't break down, but all the little additives that prevent wear and foaming and the other negative things, they break down. So, but you can run it 50 hours. I know I interviewed a company that flew Czechs in 210s, and they never changed the oil before 50 hours. And they ran their engines right out to TBO every year, but they were flying 4 and 5 hours a night. And like I said, cut the can open, look for crud. You can see a little bit of carbon in here, a little bit of aluminum. So what's in your oil? Excuse me. I'm sort of a loner. I'm not used to talking so much. But every oil has a base stock, which is about 90% plus or minus mineral oil. Some of them have synthetic. Some of the oils are synthetic or a blend of mineral oil and synthetic. They all have a dispersant, which keeps oil clean by suspending the deposits, precursors. In other words, this oil is designed so anything that drops out of the engine or anything contaminants like the carbon or whatever will be held in suspension in the oil so it can be carried to the filter. They all have a viscosity modifier. I'm sorry, they don't all, but multigrade oil has a viscosity modifier. And multigrade oil typically is 20 weight oil plus 2% of this viscosity modifier, which equals 2050 multigrade oil. They all have a little anti-wear additive, a little antioxidant additive, corrosion inhibitors, and anti-foam additive. Now, years ago, Lycoming built some engines that had some serious They didn't last very long. They're the H2AD, 0320 H2AD. There was a new design and wasn't ready for prime time when they put them in 172s and sent them out to the world in 1977. So they had to come up with a fix. An AD, three ADs were issued. One of the ADs, this one right here, AD 0403 revision 2, required a pint of this high pressure lubricant to be added over the oil change. There's a can of it right there. It's very expensive if you buy it that way. The oil vendors, never missed a trick, realized this high pressure lubricant would help their oil. So they started to add it to their oil. So you don't have to, you can either buy this stuff in the pint jar, or you can use any of these oils here if you need it as required by AD. You may see that the oil I use is not listed there. I use Phillips 2050 XC, cross country. And I'll tell you why in a minute. Now, many people say, well, should I use multigrade or straight weight? If you live in a mild climate, straight weight oil does fine. Mike Bush has used straight Aeroshell 50 and has gone way beyond TBO in his engines. I use Phillips X multigrade. It is not a semi, it is not a, does not have any synthetic component. I'll tell you why why I chose that. The synthetic component they add to oils is something called polyalpha olefin. And it's a synthetic hydrocarbon which mimics the best hydrocarbon. But does anybody remember the big kerfuffle with Mobil AV1 oil? 1980, Mobil came out and said, we got this oil, you can go 200 hours without changing it. Lubricates better than anything. Well, before long, engines were having serious problems. What happened was this old AV1 does do a great job of lubricating, but it does a terrible job of scavenging the lead that's in these engines, the lead that's a byproduct of combustion. So it cannot, it never held it in suspension. So it could be caught by the filter. And so what happened was the oil galleys would get clogged up in the engine. Those are the little tubes throughout the engine that spread the oil around, and they had main bearing distress because of oil starvation, big stink. And Mobil made everybody jump through giant hoops to get any warranty claim, and that oil was withdrawn. The outside air temp where you fly is pretty much a determining factor of which oil you should use. I just use 2050 because, I don't know, I like it. And I think it's a good combo with CamGuard. This is that oil sludge. It's in every engine, the carbon oil sludge. So that's what Mobil did not run. Did not scavenge, and it clogged up the engine. Now, if we're talking theory, the best way to run your engine is high manifold pressure and low RPM. If I had a turbocharged airplane, I'd be running about 28 inches of manifold pressure, and whatever RPM worked out to be the power setting I wanted to fly at. Most of us can't run that way. Every time I climb up to the most efficient altitude for my airplane, which is 7,000 to 9,000 feet, I can't get a high manifold pressure. So this is sort of theory unless you have a turbocharger. I'll show you why it works though. As we increase RPM, the friction inside the engine increases. At 2,700 RPM, you've almost got 50 horsepower friction loss. So there's advantage to lowering the RPM. You can lower that by, it looks like about 22 RPM, 22 horsepower just by getting down around 2,200 RPM. The other thing is that these rings on each piston are designed to push out to allow dial the pressure of combustion, the brake mean effective pressure, which is part of the combustion process, to get down behind the ring and pushed out against the cylinder wall to seal. So if you got a high manifold pressure, that seal is more efficient. You got low RPM, you got less friction loss. So there's real advantages to do it if you can do it. I can't do it. So Mike Bush, you guys all know who he is. I've known him for, I don't know, 25 years. And he says these engines are hard to wear out. If they don't make it the distance, it won't be because I wore them out. It'll because I allowed them to corrode internally because I wasn't flying often or regularly enough. So the things that reactive deposit precursors, those are the bad news that are made during combustion. Partially burned fuel, lead deposits, all that stuff. You want to reduce that as much as possible, and the only way you can reduce it is prevent it. So here's the ways you do it. The way of 5 ways you can do it. Avoid any rapid throttle adjustments unless absolutely necessary. Easy does it. Lean aggressively on the ground. Install a smart engine multiprobe monitor and use it to lean in accordance with the guidelines. Use a deposit inhibiting additive such as CamGuard, which is the only one I endorse. I know AbBlend is not something that I would spend a dime on. Change your oil every 20 to 35 hours. So changing oil removes all the bad juju and allows your engine to work clean. Excuse me. CamGuard is separate from oil. It's not added to any oil. You buy it separate. It's not cheap. It's about $21 a pint, but it's a great protector. And you can see, as I mentioned earlier, Mike will break down his the oil analysis readings into parts per hour per flight hour. So you can see as we move from left to right, the 7705 reading as 1.11 parts of iron per flight hour. The right engine has 1.22. So you can move to the 61106, and these numbers are still above 1. You move over to the next one that's outlined in red, and it's 72907. They're still above 1. Now, one thing that will cause your iron readings to be high in oil analysis is inactivity, because any rust on the cylinder walls will show up as iron or ferrous metal. So then he added CamGuard, and 3 oil changes later, look what's happened to the iron parts per million per hour, dropped considerably. And so that's just evidence it works. There's another graph which I did not include, but this stuff works. So what is a definition of flying often? They say you should fly often in order to keep your engine running. Well, Lycoming has a service letter, and Lycoming, as again I said, just like in the in the compression readings, these are sort of soft suggestions. It says desired flight time for air-cooled engines is at least 1 continuous hour with oil temperatures from 165 to 200 at intervals not to exceed 30 days. That's pretty liberal as far as I'm concerned, especially if you live near the ocean, on the Gulf Coast, in Florida. In other words, even California is wait a minute, I didn't put the map in. Even California is regarded as a high corrosion area by the engine manufacturers. So I've got a little list of places you can learn more. YouTube videos. Mike Bush has Leaning Basics and Leaning the Advanced. I can't see what that says. Ed Colin, the guy that developed CamGuard, has a number of YouTube videos. One, how to minimize problems. One, how to overhaul. He also has one about making TBO, and the subject is blow-by, minimizing problems with oil life and others. There's also one more. Oh yeah, here's another reference material. Now, every manual that Lycoming prints is available for free download. Every one of them, they're all there. You can get engine installation manual, engine operation manual. You can get a parts manual. You can get a service manual. They're all there free at that website. I also recommend everybody buy a copy of Mike Bush's Engines book. It's about 25 bucks, but it's, I've reviewed it. I've given it to a couple other very knowledgeable mechanics, and they all think that it's the best one source or one-stop source for engine information operation there is. And Mike's not a guy who just spouts off stuff. He's a guy that supports his views with research and interviews with experts. So very good book. So that's the start. That's pretty much how I've gotten, as far as I've gotten in this presentation. So I guess we can ask questions at this point. So I stop sharing. Is that the next step?
You can. Steve, that is amazing. Just thank you so much for coming and talking to us. Even for people who are, you know, really experienced with all this stuff, which I am not, I've already gotten some feedback that it's new information. What we normally do next is just, I just go to the chat window where people have generally been asking their questions as you've been talking.
Okay.
And start reading off some of the questions that have come through. If you are dialed in and you had questions, you can text your question to 617-816-8766. Again, 617-816-8766, and I'll go ahead and add those into the question list. Before, and then if once we're through the questions that have come into the chat window, then we just go to straight Q&A. And just a quick question, just because my connection was not so great earlier. How do you hear me?
5 by 5.
Good deal.
THRU. Through like THROUGH? Or through like through a ball?
Through something. No,
like,
through something.
Like THROUGH. THROUGH.
Yeah. So Steve, just first question that came up was did you say test compression on a hot engine? And if so, can you talk more about that? I'm an annual, just did our compression check on a cold engine.
Well, ideally, cold engine is a good place to start. I mean, it'll give you a rough idea, but ideally you'd like it at operating temperatures, because that's where the engine is going to be when you need compression. But you know, it's not carved in stone. It's just proper maintenance practice. Let's say that.
How much of a difference are we likely to see in compressions between a hot and a cold engine if there is a trend?
I don't know. It varies, I imagine.
Okay. Tim Howard had.
Let me expand on that. Before we had bore scopes, the way you determined if a valve was leaking or the rings were leaking was you used your ear. You put your ear down to the exhaust pipe, and you could hear a big hiss coming out of the exhaust pipe. Your exhaust valve was leaking. A big hiss coming out of the engine breather, the rings were leaking, and a big hiss coming out of near the carburetor inlet, the inlet valve was leaking. So the one you're looking for, of course, is the exhaust valve, because they don't get better. They start burning, they get hot, hot, hot.
Cool. And then Tim Howard, Pat, did you want to add anything to that? Okay.
No, that was the question. Thank you, Steve. Thank you, CJ.
Cool deal. Tim Howard had asked sodium, and I had the same question.
Yeah, sodium cooled valves, yeah. That's correct. There's a chamber inside the exhaust valve. It's filled with sodium. It's hot, and it transfers the heat up into the stem.
Oh.
Thank you.
Wow. Cool. Okay. Then we have a question about somebody whose engine is hardly burning any oil. Tom Marino's new to the type. He got a beautiful airplane about what, Tom, about 6 months ago, maybe less? And
Yeah,
Tom's
it's already that far. I got it in January. Yes.
well, happy 6-month anniversary.
Yeah.
And welcome.
Does your airplane have a new engine?
It's 550 since overhaul.
And is it a factory overhaul or field overhaul? Do you know?
Factory.
Yeah. Well, they put new cylinders on, so that's to be expected. I think you're fine.
So the 1 quart in 23 hours is no worries.
Yeah, I mean, everyone was talking about those burn rates, and I'm like, well, wait a minute.
well, the reason mine burns a lot is because, number one, I had some cylinders I could reuse, and number two, chrome cylinders do not rust, and I'm not flying a lot, so that was a plus for me, and they were already paid for, and I don't mind pouring oil in the top. I used to work on radial engines. Gotta have gallons of oil, you know.
I got told as long as you don't run out of fuel before you run out of oil, you're okay.
Yeah.
And then as we were discussing oil consumption, because Pat's twin is doing about 20 hours per quart, Robert commented that it's really, as Steve, as you were saying, that it's the consistency of the rate of consumption that counts and not the amount. Is that correct?
Yeah, you heard right. Yep.
Yeah. Let's see. So how does oil consumption change with electronic ignition?
I have electronic ignition. I have the electro air system on my airplane, and I have no idea how it changes. It should not change at all, because what are you doing? You have a hotter spark.
Yep.
Maybe
and
more
variable timing.
Yeah, and maybe that means more complete combustion, which maybe it means slightly higher brake mean effective pressure, which maybe it means slightly more oil consumption. But I can't answer that. I'm just guessing. I haven't noticed anything, except I like it.
We did a group buy that Electro Air had agreed to replicate it. We had a little hiccup, and I need to finish reconfirming we can do it, because the new group buy they're offering us is terrific. But we actually, the Comanches sold them completely out of stock. So, and then the chit chat was that people really liked the electronic ignition, and the chit chat right now is that the SureFly systems, although not the same, are delivering pretty good numbers as well. Not quite the fuel consumption, but.
Well, what the thing, like I said, I'm not the scientist Hans is, but I did notice right off the bat, this thing starts up, idles smooth. It's just, I think it's a much better, I like having it in the airplane. The only drawback I can tell you is that if your battery voltage goes below 8 volts, it departs. So that's why you have a magneto on the other side. This is old Alaska thinking, out in the boondocks, the battery's dead, what am I going to do? You got to have the magneto with the impulse coupling.
Right. So you can still hand prop your engine?
Oh, yeah.
Cool.
The commies might be coming across the inlet,
It's the old, if I'm stuck out here, nobody's going to come and fix it but me. We have a question
from Murray, how does CamGuard compare to the Aeroshell Plus oils that claim to include the same benefit?
Well, this is a good question. All of those plus oils have that high pressure lubricant in it, which is really good. Now, I asked Ed Colin, I talked to him for a while there at Oshkosh, and I talked to him once in a while on the phone. And I said, well, this extreme high pressure lubricant, this LW16702, I mean, I don't have that in my oil. Is that a bad thing? It does not in XC2050. He said, the stuff in CamGuard's at least as good, if not better. So you're not putting your engine in danger if you don't use those additized oils, as long as you put CamGuard in.
Makes sense. And then Ron asked for the ratio of CamGuard to oil, especially given the very huge variation in how much we're burning.
Well, you put in a certain amount for every quart. It's like 10%. And, you know, a little jar will last you a while. And the jars are graduated, so you pour in a quart and then you pour in a little dab of CamGuard. You know, you sort of try to keep the ratio correct.
So it just means us chrome cylinder people are a little more expensive, and Thomas Marino and Pat Keeper, you guys get to sip.
Well, look, here's my read. If you can't afford oil and gas, you can't afford an airplane. The other thing that I liked about CamGuard is, for some reason, although I hate interior work, I decided to put an interior in my airplane. So I bought a kit from Airtex in March. So guess what? I have half of the parts. My airplane's disassembled. It's dead in the water. I don't know what to do. Well, I have some plans, but so I asked Ed, I said, what's the best thing I can do to preserve this engine during a period of inactivity? He said, get it hot, run it around the patch, drain the oil, put in fresh oil and the proper amount of CamGuard, run it around the patch, get it up to oil operating temperature, and it ought to be good to go for quite a while. It has, you know, CamGuard is named after the biggest problem you have with Lycoming engines during inactivity is corrosion on the lifters in the camshaft, because the camshaft in the Lycoming engine is the top of the engine. It's way up all by itself. There's no pressure lube that goes on. It's all splash. So like Continental, conversely, the camshaft at the bottom of the engine, so all the oil that is pressurized and bearing on the crankshaft floods the camshaft. So, you know, that's a Lycoming's weak spot, and CamGuard, I think, addresses it, I think.
Cool. I happen to know of one airplane because it's in the family that's at 3,000 since major on CamGuard and Phillips. So, and flying out of the coast, about a mile from the ocean. So
nice.
That's one data point.
That's good.
Fingers crossed. Let's see. So from Tom Marino, who's, as we just discussed, has just had his 6-month anniversary. He was told he doesn't need an engine monitor for carbureted engines since you lean to roughness, but that doesn't seem to give much comfort on what's happening. And I actually have the same question. You obviously are flying a carbureted engine with an engine monitor. So your thoughts?
Well, I like engine monitors. I have to fess up that many of the products that I have in my airplane were given to me. So, you know, Mr. Media, I found my niche. I lay around in my sweatpants, write articles, and get free stuff. But this is a good story. When I was working at Cessna Pilot Association, I had a guy call up, and I tried to answer all those tech questions. And he says, my engine on my 182 is terrible. I said, wow, that sounds bad. What's wrong? Well, the temperatures are all over the place. I said, no kidding. He said, yeah. I said, well, when did you discover this? Right after I put in the engine monitor. I said, well, how's it running? Is it running badly? No, it runs exactly the same. So in this case, it was a case of too much information, you know? And you know, I don't think an engine monitor is required. I think it's handy, but I also think that just basic oil changes and correct timing and good spark plugs and flying often is probably the best things you can do. You know? Just fly that. You can't fly often enough, get a partner you can get along with. Cut the cost.
Have they used any of the other stuff?
I'm sorry?
See, I told you. What? Corn.
Hey, Lonnie, you're gonna need to mute.
We just did.
Okay, cool. And Tom, I'm just gonna throw in one quick, because it's very recent. So I'm flying a 180 carbureted, not a single EGT or CHT in the airplane or anything. I have oil temperature and pressure, and that's about it. So we just pulled the spark plugs, and the note on them, they're Tempest fine wear, so they're plugs that'll last a long time. But I've been leaning by ear as well, and the plugs are all even in color, and you know, so as we were going through looking at condition, the feedback that I just got was that means the mixture is working properly, and the leaning is working if they're all looking clean and even in color. And I think Steve, that goes to what you had just said in your presentation about plug.
Yeah,
color
plugs are another, which I didn't put in the presentation, but the color of the plugs will tell you how you're doing in leaning and how the burn is. They should be a nice sort of dark tan.
Yeah. Yeah. So that'll kind of give you your feedback. It's like a feedback loop, Tom. When you go and look at your plugs, if they're all a nice dark tan, you probably got it right, and your mixture is working okay, I guess.
Yep. The old school of leaning, which we all learned when we were in our initial flight training, was pull it back till it gets rough, push it forward till it smooths out, bingo. You know, it still works. But the thing that I didn't stress probably enough is leaning on the ground is critical.
Yeah.
Because there is an additive in avgas that vaporizes or turns the lead to a vapor-like process, or a vapor-like substance, vapor-like vapor, at a certain temperature. When you get above about 900 degrees Fahrenheit, this additive actually helps vaporize the lead, which it needs to be, lead needs to be in there for high-powered engines to prevent detonation. But so at idle, it's not hot enough for this additive to do its number on the lead. So you have lead in liquid form, which you'd like to cut that down as much as possible. So you almost cannot lean it too much on the ground. I used to actually do my engine run-ups with the engine leaned, because what power setting are you doing run-up at? Maybe 45% power. Lycoming says you can lean to peak at 75% power. You're not going to hurt the engine running it up, leaned out. If you've got it too leaned, what will happen was the RPM will gradually drop. Then you just richen it up a little bit. Continue your run up, and that way you're eliminating as much of the lead in your engine as you possibly can. Just don't forget to rush pull it all the way forward when you're taking off. The mixture, that is.
Something more to add to our on the runway departure check, huh?
Yeah, push everything forward. Handful.
So this question came up several times. Mike Bush talked about overhauling based on condition. How far can we go with this in time?
Well, you're talking about flying an engine that's 3,000 hours since DBO, weren't you? Well,
yeah.
that question. As long as you feel confident, as long as the diagnosis is good. Some people recommend when you get maybe 200, 300 hours over TBO, you start doing oil samples and investigations more often. But if one thing Mike points out in his book is engines, once they're past the infant mortality period, they pretty much go and go and go as long as you take care of them. They're designed for it. They're tough as nails. They're not very sophisticated, but they're strong. So part of it is how's your gut feel about it. Part of it is how's the diagnosis. What's it look like? How's the oil sample? Like I said, if you notice a change in anything, especially fuel consumption or oil consumption, it's talking to you. It's talking to you. You need to figure out what happened, why it's done that. And spark plugs tell a great story.
So really, until we see either a sudden change or compressions drop below 60, or we start seeing stuff in the filter, just fly the engine.
Yeah, why not?
It's cheaper that way.
Well, unfortunately, most of these engines will rust out before they wear out.
Wow.
So that's, and you can, John Frank used to say this all the time in the classes, and all you pilots can take that message home to your wife. Run that airplane a lot,
Good deal. So Chris Burnley, did you have any additional questions? Because you were the one that put that in first.
No, I think that answered it pretty well. The only other thing I would ask, which is semi-related, is the propeller. Do you take the same approach with the propeller, or do you do TBO on the propeller at a different time than the engine?
Yeah, it's a different story there. I don't have great advice on the propeller. I know that Mike is a great believer in sending it to a prop shop and asking him for a prop reseal. Because if you go in there and say it needs an overhaul, there's a list of parts they must change, no matter what the wear condition is, in order to call it an overhaul. Sometimes you don't need all those parts. So Mike's theory, which I've heard a number of prop shops say, what a pain in the ass, is that you send it for a reseal. And what a reseal is, they disassemble it to the same degree they're going to do a overhaul, but then they inspect and they replace the parts that are worn. So theoretically, it should be cheaper unless the prop's really hammered. So that's one thing you can try with your prop shop. If they agree, you can try to get them to reseal it. And 10 years is sort of the, rule of thumb, I guess. Unless you got erosion or damage,
By 10 years, do you mean reseal every 10 years, or that's as long as you're going to go?
No, I'd send it to a shop every 10 years, if not sooner. A lot of forces on the prop. They're pretty stressed. They're not really stressed. I mean, they're not at the edge of stress, but they take a lot of beating.
That was a good question, Chris Burnley. I'm glad you asked that. So Lonnie and Lauren just completed their annual. They have one cylinder at 50 PSI, but the rings were cold. Would hot make a difference? And before Steve answers, Lonnie and Lauren, did you have anything you wanted to add, or just that covers it?
Well, I certainly would not pull an engine based on one compression test.
Cool.
I would get it hot, try it again. And then if it didn't come up, then I'd fly it for 10 hours and try it again. Like I said, the compression rings can line up. And here's an interesting factoid. When I went to Continental School, excuse me, they said, we took one of our big bore engines, which would be a 470, and we took the rings off the pistons. Then we put it on our dyno to see how much power it would make. And it made 100% power with no rings.
Wow.
So, you know, that's sort of hard to believe, but that's what they told me. And so I've been meaning to call them back and find out if that's really the facts, but that's what I was told at their school.
So basically, if you get a low cylinder reading, just fly it a little bit and then check it again.
Yeah.
See if the rings lined up so that your compression improves.
Yeah. Now, as I mentioned, Continental doesn't care much about compression reading, the number, but they really care about inside the cylinder. They want to look at the crosshatch, which is on the cylinder walls, is not worn smooth. If it's worn smooth, the cylinder's worn, or the exhaust valve is leaking. That's all they care about. You can get compression readings as low as 40 pounds. They'll say airworthy as long as the valve is in good shape and the crosshatch doesn't show wear on the cylinder walls.
Wow. Lonnie and Lauren, go ahead. I heard you start to clarify something.
Yes, thank you for that, Steve. We were at 50 pounds and we haven't flown it yet. We just had the annual. And he mentioned possibly rings lining up. But it seems to me that if the rings are cold, they're not going to seal like they are when they're hot.
Exactly.
So I think we're just going to fly it for a while and then do a compression when it's hot.
Yep.
Thank you so much.
Of course.
Be comforted. Malcolm just wanted to make sure that everybody knows the recording of this excellent presentation will be available usually it's available tomorrow, depending on the post-processing team for viewing, and that's going to be at meetings.northeastcomanche.org. And so feel free to share that with all your friends who fly Lycoming engines. This is really a general interest presentation for everybody behind a Lycoming.
Well, I'd like to have one caveat though.
Yep.
This is not for general, it's for general viewing, but not general distribution. Okay.
Oh, okay. Yeah, and we cannot do this, Steve. We've said to everybody in the notice, it's up to the presenter whether it's shared or not.
Well, I prefer it if nobody copied it and sent it to their buddy. I mean, this is sort of us right now. Put a lot of work into it for us, and so that's I'm getting to be stingy in my old age.
So in that case, I think what we might do then is look into. We'll talk to you afterwards about something you're happy with, and then we'll put a note out to let people know.
I have to quit here in another 7 minutes. I've got another presentation to do. So
gotcha.
Talk about
I'm going to talk a little faster then, and just Blackstone. Stephen Merrill Shepard has mentioned that Blackstone flagged higher than normal aluminum and chrome in their last sample, and their plane was out of service for 3 months for an interior redo. Could those higher levels be attributed to the downtime?
I wouldn't be surprised. You know, my chrome readings are high because I have chrome cylinders. But if you go to Blackstone and you look on their website, they will have a list of what metals come from where. So if you got aluminum, higher aluminum, typically in a Lycoming engine, that could be the wrist pin plugs wearing a little bit in the cylinder walls. That's happened before. It all depends on how much. And like I said, I wouldn't pull my hair out unless gobs of it are showing up in a filter. Like oil analysis is micro, filters are sort of in between, and the oil screen and the belly is a macro. So don't panic, you know.
Cool. Got a bunch of questions, a bunch of compliments, Steve, to you, by the way. I'm just noting a lot of people. If you can, just go down to the bottom and hit a thumbs up, thumbs down if you feel like it. But a bunch of people are like, this is great information. Love the photos.
Good.
Thanks for pulling it together.
Wait, I like it. Thank you.
A couple other questions on additives. Phillips has Victory 20W50 with this additive now. Dave Shaver, which additive?
Oh, it's
You know the one he's talking about?
Phillips. No, I don't.
Victory 20W50?
Oh, yeah. I thought that's a Phillips oil. I thought it was a Shell oil.
Yeah. Dave Shaver, if you're there, you could unmute and clarify. Otherwise, quick question from Lonnie and Lauren. He's got 1,600 hours on his fine wires. How long do they last?
Oh, they can last a long time. I mean, typically, there's been studies by Ram Aircraft that economically a fine wire is a better plug economically. It fires a little hotter. The spark is not shielded by the electrodes. They last. They claim they last 4 times as long as a massive electrode. Massive electrodes typically good for 350 hours, perhaps. So you can get up to 2,200, probably 2,200, 2,000.
Cool. So potentially, as long as your engine goes, how do you know when to replace your fine wires?
You visually check them for wear on electrodes.
If you can't gap them anymore, they need to be replaced.
You don't do a whole lot of gapping on fine wires. They hardly erode, and you do never put a fine wire on a bomb cleaner. You don't do that. If you want to know all about how to clean your spark plugs, go to Tempest. They have a very definitive handout on how to clean spark plugs, and most of us just take a little hand tool and chip the lead out of it, clean the threads, put an anti-seize on it, make sure the inside the barrel that the little contactor in there is clean. Good to go.
I bet you just saved some of us some pretty big dollars and trouble. You said you wouldn't use.
That's a little time,
Yeah. Another quick question from Bulldog. You said you wouldn't use AvBlend, but we were curious about the explanation. What's up?
The only thing I really know about it, although they advertise in the magazine I write for, is that a company, Aviation Consumer, used to be a guy named Kaz Thomas, and Mark Cook did a little experiment, and they tried to verify the claims made by AvBlend as far as friction, horsepower, etc. And in their little, I don't know how scientific the study was, but they didn't find any. The claims were not verifiable. Let's say that.
Yeah.
So, but they spend a lot of money on advertising. So some people like it. I just don't know much about it except just what I read there. I've never used it.
Mm-hmm. Well, you're getting great results with CamGuard. What's the best RPM setting to balance the prop at to best serve all power settings?
They basically say your normal cruise RPM, but I just did a seminar with one of the prop balancing or webinar. Everybody's doing webinars now. You sit in front of your computer all day, but they basically say anything above 2,200 RPM will suffice. My engine is real smooth at 2,700 RPM, not as smooth at 2,350. So I've got to get my balancer out, go to town. But that's down on the list.
Wonderful. Just a quick note to everybody that a prop shop inspector friend tells Part 91 flyers to reseal on calendar and overhaul on prop time. Don't know if you want to comment on that, but
I defer to the prop shop guy.
And I think to respect your time, we will wrap it up here. But I cannot tell you how many people, I don't know if you can see the chat window, but all the comments about And if, you know, the great presentation, the service letters were terrific. The photos were wonderful.
Okay. There's one question about Marvel Mystery Oil.
Yes. Oh, you do have time for that. Great. I'm curious too.
Well, why don't you take it to your favorite lab and ask them to analyze it? It's light machine oil and perfume and a little bit of, I mean, that's what I've heard. Now, I've also heard that people will, I put some in my gasoline when my valves are sticky and the engine got better immediately. So, you know, why don't you call up Shell and ask them if they recommended mixing it with their oil? I'm sure they'll say no, because it thins out the oil.
Mm.
But anyway,
wow.
I used to love buying Marvel Mystery Oil because the can was so cool. Now they're going to plastic cans, so I don't like it so much anymore. Anyway.
Dang, it's all about marketing.
Yeah. Okay.
Wow.
Goodbye, everybody.
Awesome.
Thank you.
Thank you.
And
Thank you, guys.
let me know how I can help further. Okay.
All righty, and we'll be in touch on everything else. We are gonna ask you to come back once the FAA's had a chance to go through, and they said yours qualifies. So
yeah,
we're looking forward to having you back again when that's in place.
Okay, I got some more stuff.
All right, and thank you everybody else who's been joining the Thursday sessions and making us better, stronger, faster as a fleet.
Okay.
All right.
Make sure to put the landing gear down and don't run out of gas.
And keep the sunny side up.
That's right. Bye-bye.
Bye, all. Thanks. And for anybody else that just wants to chat, we can keep this open for a couple of more moments, and then we'll let the presenters, rather the recording guys, start to get this wrapped up.
Yeah, I'm going to turn off the recorder at this point and see you guys later. Bye-bye.
All right, thanks, Pete. And anybody who's left, we'll keep this meeting open. Looks like there's about 30 people still hanging. And if you guys just want to hang or fly or chat with each other, for those who are dialed in, I believe *6 will let you unmute and talk to the group.